In this video, I have two examples for you of problems that you might come across in your assignments that might be a little confusing. So I want to show you a couple similar examples. Okay, here's our first one. If the integral of f of x from 1 to 3 is equal to 2, and the integral from 1 to 6 of f of x is equal to -1, then what's the value of the integral of f of x from 3 to 6? Okay, they don't give you much information here, but especially because you don't have a function like f of x equation to integrate. This is just a fundamental theorem of calculus problem. So what you can do is start out by remembering that formula is f of b minus f of a after you integrate. And the question is asking, what's the integral from 3 to 6? Well, that would look like this if you integrated. So remember, this is the velocity function and this is the position function. But either way, when you're done integrating, you're going to end up looking for f of 6 minus f of 3 on the position function. And we're actually given that information in those other two integrals in the problem. So let's start with those. So this is the first one, the one that equals 2, and then the other one, the one that equals -1, these two things right here. So if you integrate each one of those, it would look like f of 3 minus f of 1 for this one, and that all equals 2. Like this integral is equal to 2, so that's what this is equal to. And then same thing here, this is f of 6 minus f of 1, and that equals -1. So all you really need to do now is a little bit of algebra, because notice, in what we're looking for f of 6 and we're looking for f of 3, and we have both of those in each of these equations here. So if we just do a little algebra, I'm going to add this f of 1 over, I'm going to add this f of 1 over, and we end up getting 2 plus f of 1 for this one, and -1 plus f of 1 for this one. Well, now this allows us to plug in. We have f of 3 that can go right here, and we have f of 6 that can go right here. And we just have two expressions that we're going to use to plug into those two spots. So f of 6 minus f of 3 is really -1 plus f of 1 minus 2 plus f of 1. That's what this is here. And again, this is just algebra. We can distribute this negative sign here. That's going to be -2 and negative f of 1 now. And those two f of 1s cancel out. This positive one and this negative one makes 0. So we're left with f of 6 minus f of 3 is equal to -3. It seems a lot harder when you read the directions and you don't have anything to go on, but that's all it was using the fundamental theorem. Okay, let's move on to the next one. What is the total area bounded by the graph of f of x equals x cubed minus 4x squared plus 3x and the x-axis? So bounded by the graph of that function and the x-axis. So first, let's do a little pre-calc review, and I'm going to factor this, find its zeros. It's a cubic function, and it's a positive here. So when you think about end behavior, it's going to go down to the left and up to the right because it's an odd exponent and it's a positive coefficient. So it climbs to the right and they go in opposite directions because of the odd exponent. So if you factor, you can take out an x on all three of these, and then you're left with this, which you can factor further, and we get 3 x-intercepts, one at x equals 0, 1, and 3. So there's our picture, approximately. Well, I guess this is exact since I graphed it. Okay, so now the question is asking for total area. So in this chapter, you've learned that area under a curve represents the integral, and if it's above the x-axis, it's positive, and if it's below the x-axis, it's negative. So if we were just going to integrate f of x as is, and if you just look at the picture here, the answer would most likely be negative because, and I guess this would be going from 0 to 3, because this is 3 right here. That answer would be negative because there's more negative area than there is positive area. So the displacement, which means that it's just like a subtraction problem, you would end up with a negative number because the negative area is greater here. But the question is asking for total area, so it's not really wanting what we're saying here, which is a subtraction problem. It actually wants to know what's the actual area of this, what's the actual area of this, like the absolute value of that, what's the actual value of the area, and then combine them. So we have to think about this one as a positive value, even though it's below the x-axis. When it asks for total area, it's like asking for the area of something, which is always going to be positive. So if we did the integral like this, it's not going to think like that. It's going to give us this area down here is going to be negative. So what we have to do is split this up. Split it up into two pieces. First piece goes from 0 to 1 because that represents the one part above the x-axis. And then the next piece goes from 1 to 3. And when we integrate this piece, we're going to expect that answer to be negative because it's below the x-axis, but we'll just need to make sure it's positive before we add it to the other piece. So here's what this looks like, and not my handwriting. So you have 0 to 1 of our f of x function plus 1 to 3 of our f of x function in absolute value, but you don't integrate them differently. I know there is a formula for the absolute value of an integral. It's a really complicated formula. You hardly ever use it. I honestly don't even know it by heart because I can't tell you the last time I've used it. I just, like, anytime you deal with absolute value in integration, a lot of times you're just trying to think like that number has to be positive. So remember, after you integrate it, like normal, you're going to make that number positive. So we just need to remember to make this positive when we're finished. Okay, so let's integrate. This is power rule stuff. So this will be x to the fourth over 4. X cubed over 3, but times it by 4, and this will be x squared over 2 times by 3. So these are both going to look identical after we integrate. Looks just like this. X to the fourth power over 4, x cubed over 3, x squared over 2, with the coefficients there still. Okay, now this one's going from 0 to 1. This one's going from 1 to 3. So this is just a bunch of math, algebra really. We plug in our 1, we get 1/4, and 4/3, and 3/2. And then if you plug in 0, you're going to get 0 for all of these. So that's the first piece. Second piece gets kind of icky because you're plugging in a 3. 3 to the fourth power is 81, so it's 1 times 81 over 4. 3 to the third power is 27, so this one's 4 times 27 over 3. And then 3 to the second power is 9, so this one's 3 times 9 over 2. That's the first piece. And then the second piece is to plug in that 1. So 1/4 again, negative 4/3, positive 3/2. And I'm a big fan of not using a calculator, so we're going to do all of this by fractions. So we can get common denominator. 4, 3, and 2 is 12. And if you simplify, I love that I skipped that step. Simplify, so this would be 3/12 minus 16/12 plus 18/12 for that one. And this one's a little uglier. I'll let you do that math. And honestly, if you notice, this one and this one are identical. So once you do the first one, it's when you plugged in a 1, you can do the second one. So the only hard one here is that middle one. And then remember, this piece here is the part that's from the second integral. So that's why I have it an absolute value symbol here. Keep going, simplify. Negative 27 and negative 5 makes negative 32. That's the area here. So this area here is 32 over 12. Or if you want to simplify that, you can. You don't have to simplify. If you're an AP student, you don't have to simplify ever. unless you're like it's a multiple choice question and you're trying to match your answer to one of the choices. But if you left it as 32 over 12, if that was the final answer, you would be totally fine. It's not wrong. It's mathematically equivalent, and that's okay. Okay, so this is a positive 32 over 12 though. So final answer is 37 over 12 here. So total area means to take the area above and the area below and add the actual area. So that means making the bottom, making the negative area, making it positive before you add it to the other one. All right, that's it. Thank you.